Hello everyone, I'm Srinivas Kandatla. The project title is Unsupervised ML Netflix Movies and TV Shows Clustering. The project type is EDA Regression Classification Unsupervised Learning. Comes to project summary. This project analyzes Netflix content library using unsupervised machine learning to cluster movies and TV shows into meaningful segments. So in this we include EDA regression, classification, and unsupervised learning to sort the Netflix data. So here is the GitHub link of this project. The problem statement is the Netflix content library is a vast dynamic collection of thousands of movies and TV shows for stakeholders in areas like content acquisition, marketing, and personalization. Understanding the large data structure or data of library is a significant challenge or task. So simple metrics and insufficient level to enhance patterns or identity distinct content categories that resonate with different audience segments. So this project aims to address the challenge by applying unsupervised machine learning techniques to uh, to the Netflix catalog. The primary objectives is to develop the robust clustering model that groups the similar content based on features like uh, description, cast, and director. Uh, the resulting cluster will provide a data-driven framework for understanding the content landscape, enabling more efficient content. So, first step is to know our data. So, from google.colab import files, this is used to import the CSV file which is present in our local disk. So first we have to import the pandas. Pandas is used for reading data like CSV or Excel files. So next is import NumPy. NumPy is used for calculating numerical terms like in mathematics, and it is also used for matrices, accessing the matrices. And next one is matplotlib. Matplotlib is used for visualization technique. So it is used for visualization. And next one is Seaborn. Seaborn is also a visualization technique or library. It is mainly used for pair plot and heat map. So next is dataset loading. In dataset loading, we use a function called pd.read_csv. So in this we upload the CSV file. So pd.head gives us the entire content of the CSV file. So first data set view, df.head gives us the entire data set. So next one, data know the data set rows and columns. So df.shape gives you number of rows and columns. So here are the 7,787 rows and 12 columns in the data set. So dataset information, dataset df.info gives us the information of the dataset. So you can see in this there are range index 7,787 entries to uh, 0 to 7,786 dataset columns. There are 12 columns. So you can see that it is in a structured format. So duplicate values. So to count duplicate values, we are using duplicate count, and we are counting the number of duplicate values here. Hmm. So you can see here there are zero duplicate rows in the dataset, missing values or null values. So df dot is null gives us number of null values or missing values. So here are these are the missing or null values. Next, visualizing the missing values. So here we are visualizing the missing values using heat map. So you can see the director cast community has some missing values or null values and rating as 1. So the dataset contains 7,787 rows and 12 columns describing the content of the Netflix. Uh, Here the significant missing values are in the director, which are 2,389 and cast 718 and country 507 columns. So understanding the variables. So df.columns gives the number of what are the columns, show ID type, and these are the total 12 columns in the dataset. So df dot describe gives the total count, mean, standard, mean 25%, 50%, and maximum. So variables description here show ID gives unique ID for each title. Type the category of title, movies or TV show. Title, the name of the movie show. Director, the director of the movie. Cast, the main actor involved. Country, the country which content was produced. Added, date added, the date the content was added to Netflix. Release year, the original release year of the content. Rating, the maturity rating of the content. Duration of the content listed in the genres of content belong to description, a brief summary of the content. Check the unique values for each variable. So for checking the unique values, we use df of column dot unique function. Here are the unique functions we got in the dataset. You can see here. So data wrangling consists of cleaning data and other things, handling missing values, cleaning data, and user convert into structured format. You can see that missing values and null values are removed here. So what are the manipulations have done here? Uh, the missing values in the data set for the category which in missing values enter directory country. I fill them with placeholder unique to retain the data for text-based analysis. So data visualization. So in data visualization, I have used this pie chart. In this, TV shows and movies are included. There are 69% 0.1% of movies, 30.9 are TV shows. A pie, why did you choose the specific chart? Because a pie chart is perfect for showing the promotional distribution between small number of categories. Here it clearly and immediately shows the balance between movies and TV shows. So chart 2, in the chart 2, we are used a line chart which shows the number of titles added and year added. So here in between 2018 and 2020, there are more number of TV shows and movies. Comes to chart 3 visualization code. Uh, Here we are using vertical bar graph. So here seeing number of titles with the rating, and chart for horizontal bar graph. Here top 10 content producing countries on Netflix with country. Chart 5 top 10 most common genres on Netflix with genre. Chart 6 here the distribution of movies on Netflix, number of movies. Okay. So here you can see the median in between uh, 50 and 100, that is 98. So comes to chart 7. You can see the distribution of TV shows by number of seasons of number of TV shows, number of seasons. Chart 8. Content release year versus year added to Netflix. Year added to Netflix. Here you can see from 1950 to 2020. Here the release year. Uh, Green color dot shows the TV shows and orange shows movies, and red dotted line added the same year as release. So chart 9, rating distribution of movies versus TV shows. Here the uh, here the graph is between count and rating. And chart 10, here you can see the top 10 most frequent actors on Netflix, actor and number of titles. So here you can see like J- John Slees, Om Puri, like that, actors versus number of titles. And chart 11, distribution of movies durations by rating, duration minutes, rating. So you can see the duration versus rating here. Comes to chart 12, distribution of TV shows, season by rating, rating with the number of seasons. And chart 13, the chart 13 top 10, top 15 most prolific directors on Netflix, director and number of titles. Here chart 14, correlation heat map. Here you can see the various fields, release year, year added with release year, year added. So you can see the heat map, correlation heat map of numerical features. Chart 15 pair plot, a plate plot of numerical features by content type, release year, year added, release year, year added. So blue color dot shows the movies and orange color dot shows TV shows. So hypothesis testing. So based on the chart experiment, our EDA, here are the three hypothetical statements that can be statistically tested. Uh, first one is this hypothetical test is there statistically significant linear correlation between shows was added. When it was added to Netflix, null hypothesis, there is no linear correlation between release year and content of the year added to the Netflix. So alternative hypothesis, there is statistical significant linear correlation between release year and content and the year added to the Netflix. Perform an appropriate statistical test. So here I have performed the statistical test to obtain p-value. So he have evaluate p-value that is 0.000. Conclusion, it is rejected the null hypothesis. There is a statistical significant linear correlation between release year and year added. So hypothetical statement 2. Here the hypothesis test if the average runtime of a movie is consistent across the several different maturity ratings. So here the categories are G, PG, P13 and R. So to perform appropriate test, perform statistical test to obtain p-value. So here p-value is 0 and f statistic is at 24.38.41. Conclusion, it rejects the null hypothesis. There is a statistical significant difference in durations among the different movie ratings. So hypothetical statement 3. This hypothesis tests whether the type of content produced is associated with the country of origin, specifically comparing the United States, the United Kingdom. Null hypothesis, the content type or movies or TV shows is independent of country of production. United States or United Kingdom, the proportion of movie to TV show is the same for both countries. So alternative hypothesis, the content type movie or TV show is depend on the country of production. The production promotion of movies to TV show is different between two countries. Perform appropriate statistical method. Here I perform statistical test to obtain p-value. So I got p-value is 0.01 and chi-square statistic is 90.2524. The conclusion reject the null hypothesis. There is a statistical significant association with difference between country type and content produced. 6. Future engineering and data preprocessing. Here for handling missing values, I have used the following df dot fill na where unknown in the unknown unknown placeholder. Strategy 2, drop the rows with missing categorical data. So in place of data added comma rating, in place there is a true. If I have filled with data added and rating, the most important step. So here data dot index replaced to true, drop is equal to true, in place true. Data cleaning has been done. So here handling outliers. So you can see that outliers are handled. This is the outlier detection for movie duration in minutes. Categorical encoding. So here the shape of encoded features are 7,770 rows and 46,302 columns. Uh, Textual data processing. Now, here we install queue contradictions uh, from the output from expansion before expansion and after expansion. You can see the difference. And lower casing. Here in the lower casing, have converted the all uppercase into lower cases, removing punctuations. Here, all commas and inverted comma like punctuations are removed, removing URLs and removing words and digits containing digits. So you can see that URLs are removed and digits also removed in the content, removing the stop words and removing the white spaces. So you can see that stop words and white spaces are removed. Uh, Here only stop words are removed. White spaces are removed from here. Rephrase text in this after before lemmatization and after lemmatization. Here you can see the changes. Tokenization. We convert all the content to the tokens like horror one token, movie one token, and etc. Text normalization. Here in the text normalization, we convert before stemming and after stemming. You can see the difference. Parts of speech tagging. You can see the content, drama, noun and noun, thriller, noun and noun, etc. Text vectorization. So it gives us a shape of the matrix 7,770 and 5,000 rows. Future manipulation and selection. So in this original shape is 7,770 rows and 5,000 columns. The shape of new future matrix after SVD is 7,770 rows with 100 columns. So variance explained by 100 components is 0.16%. Future selection. The future selection, the final features have been selected for the clustering model. The shape of final feature set is 7,770 rows and 100 columns. So data transformation. So no data transformation was performed as it is not necessary for the SVD components. Data scaling. Here the data has been successfully scaled. You can see the shape like number of rows and columns. Dimensionality reduction. Here you can see the output after dimensionality reduction. Uh, Your total variance explained by 100 components is 15.92%. So data splitting. The data is ready for clustering. No train and split was performed. The shape of data modeling is number of rows and columns. You can see 7,770 rows and 100 columns. Handling ML model implementation. So here first implemented the k-means clustering ML model and evaluated the score metrics. You can see. So in this ML model used to performs using evaluation metric score chart. So you can see the metric score chart here, cross validation and hyper parameter tuning. So you can see the output here. Successfully applied optimized k-means clustering and assigned data points to clusters here. Here you can see the few rows with their new optimized cluster title and clusters optimized. ML model 2. Here you can see its performance using evaluation metric score chart with number of clusters and inertia, cross-validation and hyperparameter tuning. You can see the score for optimal K with number of clusters and uh, threshold score. And next ML model 3 implementation. Here datagram on sample data to find optimal K, data points and Euclidean distances. You can see the first few rows with their new clusters, titles, and cluster aggregations. So In this evaluation metric score chart, you can see cross-validation and hyperparameter tuning, implementation with hyperparameter optimization techniques like grid search, random CV, Bayesian optimization, etc. So you can see the testings like k equal to 8 to k equal to 15. You can obtain also the scores. You can see the first few rows with their optimized clusters. So 8 is future work. So after performing all tasks, the ML model saved should be saved in the pickle file or joblib file for further deployment. So again, we have to load the saved model, try to predict unseen data from sanity check. So I have done in this. So therefore, conclusion: this project is successfully performed a comprehensive analysis of the Netflix content library, illuminating in development of unsupervised learning model to segment content into meaningful clusters. So in this we have performed EDA regression and clustering and performed many ML models. So we can visualize the Netflix data into a structured format. Thank you.